Friends, welcome to the class. Today we'll discuss about real numbers. What is real numbers? Real numbers are the numbers which can be used in all arithmetical operation. They can be represented in the number line. In other words, real numbers can be defined as the union of the both rational and irrational numbers. They can be both positive and negative. All natural numbers, decimals, fractions come under real numbers. The real numbers are denoted by R. We'll see the details of the real numbers and their detailed bifurcation in detail. The flow diagram of real numbers are as follows. So the real numbers, it's the union of two rational numbers and irrational numbers. Again, rational numbers is further divided into two parts, that is integers and non-integers. Integers are divided into further two parts, that they are whole numbers and negative integers. And whole number is divided into further two parts, one is 0 and the other is natural numbers. So beside each definition, the examples are given. The rational numbers is maybe positive, maybe negative, 0 or fractions like -2, 0, 11, 4, 7 by 6, -10 by 9. These all comes under rational numbers. Whereas irrational numbers are √2, √11, -√3. These are irrational numbers. And this union of irrational numbers and rational numbers constitute real numbers. Now, if we go into detail of the rational numbers, it is divided into two parts, that is integers, which are positive, negative, and 0, and non-integers, that is the numbers which can be expressed in terms of p by q. They are non-integers like 5 by 6, 7 by 11, -3 by 8. Again, the integers are further divided into two parts. They are whole numbers like 0, 1, 2, 3, and the negative integers -10, -9, -21. Again, the whole numbers are divided into further two parts. They are natural numbers like 1, 2, 3 up to infinity and 0. Now let's understand rational numbers and irrational numbers in detail. Any number which can be expressed in terms of p by q, where p and q are the integers and q not equals to 0, is called rational numbers. For example, -2 by 7, -15 by 40, 26 by 9, 8 by 13, etc. That means the rational numbers can be positive or negative. Now, what is irrational number? Any number which can't be expressed in the form of p by q, where p and q are integers and q not equals to 0. For example, √3, √5, √17, pi, etc. Let's see some theorem. Theorem 1. If p be a prime number and a is a positive integer, if p divides a square, then p divides a. So given p is a prime number and a is a positive integer such that p divides a square, let's go for proving it. We know that every positive integer can be expressed as the product of primes. So let a equals to p1 into p2 dot up to pn, where p1, p2, p3 continues up to pn are the primes. So a square equals to p1 into p2 into p3 dot up to pn whole square, or it can be written as p1 square into p2 square continues up to pn square. Since p divide a square, we can say p is a prime factor of a square. So p is one of the p1 or p2 or p3 continues up to an, pn, or this implies p divides a, because a equals to p1 into p2 into p3 dot up to pn. That means this implies if p divides a square, p divides a. Hence proved. Let's see another theorem. Theorem 2. √2 is irrational. To prove it, let us assume that √2 is a rational number. So we can express √2 in terms of p by q, where p and q are the integers and q not equals to 0. Again, p and q should not have any common factor other than 1. So √2 equals to p by q, where p and q are co-prime integers. Now let us understand in detail. We have assumed √2 is a rational number. So we are expressing root 2 in terms of p and q. Root 2 equals to p by q. So it is quite clear, since root 2 equals to p by q, there is no common factor between p and q other than 1. Therefore, p and q can be called as co-prime integers. So on squaring both sides, we get 2 equal to p square by q square, or 2q square equal to p square, which is equals to, let this be the first equation. So this implies 2 divides p square. But as per theorem 1, if 2 divides p square means 2 divides p, so we can write p as a multiple of 2. That means p can be written as 2m, where m is the integer. On putting p equals to 2m in equation 1, we get 2q square equals to 2m whole square, or 2q square equal to 4m square, or q square equal to 2m square. Again, this implies 2 divides q square. That means 2 divides q. Thus, here we got 2 is a common factor between p and q. But already we have assumed there is no common factor between p and q other than 1. But here we got 2 is a common factor between p and q. That means our assumption is wrong. Thus, we can say root 2 is irrational. Hence proved. Let's see some example. So that 3 root 2 is an irrational number. Let us assume that 3 root 2 is a rational number. So it can be expressed in terms of p by q, where p and q are the integers and q not equals to 0. So we write p by q equals to 3 root 2, or it can be written as p by 3q equals to root 2. Since p is an integer and 3q is an integer, so 3q not equals to 0, or p by 3q is a rational number. This implies root 2 is a rational number. But we know that root 2 is an irrational number. So this contradicts the fact that root 2 is an irrational number. Therefore, our assumption is wrong. Hence, 3 root 2 is an irrational number. Hence proved. Prove that 2 plus root 3 by 5 is a rational number, given that root 3 is an irrational number. Let us assume that 2 plus root 3 by 5 is a rational number. So you can write 2 plus root 3 by 5 in terms of a by b, where a and b are the co-prime integers and b not equals to 0. Co-prime integers means there is no common factor between a and b other than 1. So now we can write 2 plus root 3 by 5 equals to a by b, or on doing cross multiplication we get 2b plus root 3b equals to 5a, or 5a minus 2b equals to root 3b, or 5a minus 2b whole divided by equals to root 3. Since 5 and ab are rational numbers, we can say 5a minus 2b by b whole divided by b is a rational number. That means root 3 is also a rational number. But it is already given that root 3 is an irrational number. This contradicts the fact that root 3 is an irrational number. Thus, our assumption is wrong. Hence, 2 plus root 3 whole divided by 5 is an irrational. Hence proved. Prove that 2 root 3 plus root 5 is an irrational number. Let us assume that 2 root 3 plus root 5 is a rational number. So it can be written as in the form of a by b, where a and b are the co-prime integers and b not equals to 0. Now 2 root 3 plus root 5 equals to a by b, or 2 root 3 equals to a by b minus root 5. On squaring both sides, we get 2 root 3 whole square equals to a by b minus root 5 whole square, or 12 equal to a square by b square plus 5 minus 2 root 5 into a and by b, or 2 root 5 a by b equal to a square by b square minus 7, or we can write root 5 equals to a square minus 7b square whole divided by b square into b by a, which is equals to a square minus 7b square by 2ab. Now a square by 7b square whole divided by 2ab is a rational number. This implies the root 5 is also a rational number. But this contradicts the fact that root 5 is an irrational. So our assumption is wrong. Hence 2 root 3 plus root 5 is an irrational number. Hence proved. Friends, here we saw few questions. The more and more questions you practice, the easier it becomes then, and the more you like it. So friends, practice more and more such questions, and in case you come across any difficult question, do share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, in solving your question. So this much for today's class. Thank you.